Algebra 1, Lesson 118. We are looking at combinations today, which relates to the lesson earlier about permutations. So if you're unclear about permutations, make sure to watch that video before doing this one. But we are looking at lots of different problems involving combinations. Now, the difference between permutations and combinations is this. With permutations, the selection of the items where order does matter, meaning if I have books A, B, and C, a different order for this, a different selection would be C, B, A. So the order does matter, and those are two different situations. Combination, on the other hand, is the grouping of items where order does not matter. When I have A, B, C, and C, B, A, well, I would actually cross out one of these different ones because the order doesn't matter. It doesn't matter if I have C first or C last. We still have those three books, A, B, C. So we're going to look at lots of different examples of this and see how we can change the permutation formula in order to use it for combinations. It's just a slight change. So a teacher puts 4 essay questions on the test. They're labeled A, B, C, D. Students are required to choose 3 of the questions. How many permutations of the 3 questions are possible? So if I just wanted to know where order does matter, it matters if you chose A first and B second, rather than B first and A second. Let's see how many total permutations there are. And if I do this, I'm going to use my formula n permutation r equals n factorial over n minus r factorial. Now remember, n is the number of items I have, so the total number of items, and r is how many number I choose. So if I plug this in, I'm saying I have 4 different items, so 4 factorial over n minus r. So I'm choosing 3 of them, so I do 4 minus 3 factorial. In this case, 4 times 3 times 2 times 1 gives me 24 over 4 minus 3 factorial is 1 factorial, so just 1. Meaning I have 24 different permutations of these essay questions when I pick 3 of them. Meaning if order mattered, there would be 24 different tests that could be taken for this. But does it really matter what order you do these questions in? And the answer is no. So if I write down all of the possible permutations, we would have this list right here, all 24 of them. But if I have all 24 of them and the order doesn't matter, then it means that if I have A, B, C, those 3 questions being chosen, BAC is the same, CAB is the same. All of those that have A, B, and C in them, I can cross out because those are really just the same as A, B, C. So we can cross all of those out, and we end up basically seeing if I have ABC, ABD, ACD, and BCD, those are the 4 that are unique to this ordering. There's only 4 of them that actually matter here when the order doesn't matter. Those 4 are the only combinations that I care about with this test. So what has just happened? I have just gone from 24 possibilities to only 4. I've really just cut this by 6. Well, when we look at this 6 right here, what this actually is 3 times 2 times 1. It's 3 factorial, which is actually the number of items that I'm taking. So all we're going to do to change this permutation formula is say if my permutation formula is n factorial over n minus r factorial, I am going to divide that by the number of ways to order r items. And there are 6 in this case. Remember, I'm just going to say this again. If I want to know how many ways to order r items, if I have 3 items, basically I have 3 buckets. In the first bucket, I have 3 possibilities for the first one. Well, once I have something in that first bucket, I now only have 2 for the second one and only 1 left for that last bucket. So the number of ways to order r items is 3 factorial. So I divide by that to get the combinations that I want. So I divide by r factorial as well. And this is my formula for combinations. Basically getting rid of all of the duplicates, saying I don't need all of those possibilities because I don't care about the order. ABC is just as good as BAC. So let's actually put this into practice here. A restaurant has 2 side dishes that can be chosen. There are a total of 6 side dish choices. How many combinations are there? This is a combination problem because it doesn't matter that I get macaroni and a side salad or a side salad and macaroni. No, the order doesn't matter. I get those 2 side dishes. So one way, if they don't tell you if it's a permutation or a combination, think about logically, does it matter what order I have these people in? Sometimes it does with things like maybe winning first through 6th place at a track meet. The order there does matter. We want to put the people in their correct order. But if we're talking about side dishes, it does not matter. So let's plug our information into our formula, and we say, all right, n is how many total possibilities there are, and we say there are 6 side dish choices. We want to choose r of them. We want to choose 2. So let's plug it in and say 6 factorial over the number of ways to order those r items, and then just like a permutation, n minus r, so 6 minus 2 factorial. When we work this out, I have 6 times 5 times 4 times 3 times 2 times 1 over 2 factorial, so 2 times 1, times 6 minus 2 factorial, so 4 factorial, 4 times 3 times 2 times 1. I'd very much recommend actually writing this out when you're first doing it so that you can see how much you can simplify here. I can simplify all of these 4 factorial, and then I can also simplify the 2 and the 6, meaning that I just have 3 times 5, which is 15. If you worked this out beforehand and actually multiplied it all out, you get 720 over 2 times 24. Ends up being the exact same. It still gives you 15 different choices for how these side dishes can be chosen. 15 different combinations where order doesn't matter. Okay, how about this one? In a class, there are 8 report topics. A student must research 3 of them during the year. How many combinations are there for the student? Because it doesn't matter the order. They can choose these in any order, doesn't matter. So we have n amount of report topics, which is 8, and a student is going to choose 3 of them. So we plug it in and say 8 factorial over 3 factorial times 8 minus 3 factorial. Now I'm not going to write all of these numbers out again. I'm just going to say 8 times 7 times 6 times 5 factorial over 3 times 2 times 1 times 5 factorial. I know that all of these are going to cancel out there. That 5 factorial is the same. And I wrote out 3 times 2 times 1 so that I can simplify some of these different pieces. Like 3 times 2 is 6, and 6 cancel out. So I end up with 8 times 7, or 56 different combinations of these students picking these report topics. All right, a few more here. At a salad bar, there are 20 types of food. Each customer is allowed to choose 15 of them. How many combinations of the plates can be made? Well, there are 20 different types of food, and we are choosing 15 of them. It doesn't matter if we put the cheese on top and then then the carrots. It doesn't matter the order. We can put carrots and then cheese. It doesn't matter at the salad bar what you choose first, so it's a combination. And we plug it in to say 20 factorial over, well, the different ways to order those are choices, so 15 factorial times 20 minus 15 factorial. So there's a lot that can cancel out here. I'm going to write out 20 times 19 times 18 times 17 times 16 times 15 factorial over 15 factorial times 5 factorial. Those 15 factorials cancel out, and you could go through and cancel out some of those 5 times 4 times 3 times 2 times 1 with the numbers above, but take some time and actually multiply it out. This is a good one, honestly, for a calculator, just to make sure that you're getting the correct amounts. But when you do work through all of those different amounts, it's a pretty big amount. There are a lot of different ways to make these combinations. There's 15,504 combinations of salad toppings. And that's with order not mattering. Think about how many you would have when order does matter. A ton more. Okay, I believe I have 2 or 3 more questions here, and we'll get into a little bit of probability here after this one. So a company delivers fruit to its customers every month. There are 16 types of fruit. Each customer can choose 12. How many combinations can the customer make? Once again, order doesn't matter here. You get peaches, then apples, or apples, then peaches, doesn't matter. So we say I have 16 choices and I'm choosing 12 of them. So 16 factorial over 12 factorial times 16 minus 12 factorial. So 16 times 15 times 14, 13, and 12 factorial over 12 factorial times 4 factorial. And I'll say we have 3, 2, and 1, so I can simplify easier. The 12 factorials go away. I can simplify, let's see, the 4 and the 16 pretty well, the 3 and the 15 pretty well, 2 and the 14. So really all I have to multiply is a 4, 5, 7, and 13. That's not too bad. And when you do that, you have only 1,820 ways to get these different combinations of fruits. Not too bad. Okay, so now with these combinations, we can do a little bit of probability. Actually, pretty simple probability. What we're going to do is find the combinations that are possible and saying only one of those will give me the correct choices that I want. So an animal shelter has 20 dogs. Each month, 3 of the dogs are randomly chosen to be pets of the month. What is the probability Oakley, Thor, and Crush will be selected? Well, let's figure out how many combinations there are, because it doesn't matter if Thor gets picked before Crush or Crush before Thor. We don't care the order. So let's find the combinations possible. Well, we have 20 dogs with 3 of them being chosen. So I have 20 factorial over 3 factorial times 20 minus 3 factorial. We do 20 times 18 times, missed a number, 19 times 18 times 17 factorial over 3 times 2 times 1 times 17 factorial. 17 factorials go away. I can simplify the 3 and the 18 here, and I can simplify the 2 and the 20 here, and I'm going to multiply 10, 19, and 6. When I multiply those together, take a second to do that for yourself, of course, but I end up with 1,140 ways to choose these dogs. Well, if I want to know what's the probability of these 3 in particular being selected, there's only one combination with those 3 in there. That's what we've assured. There's only one. So I have 1 out of 1,140 that get chosen. Okay, that's the probability of those 3 themselves, just those 3 getting chosen. If it were a little bit of a different question and it said, what's the probability that they will not be selected? Well, then I would have the reverse of that. All of the other choices, all 1,139 of them, would be combinations that don't have those 3, and out of 1,140. So we just have the complement to it if we were to say, what's the probability that they will not be selected? All right, last question here, very similar to the one that I just did, so hopefully you can do this before I show it in the video. A student has 20 stickers and wants to trade 10 of them. A friend randomly chooses 10 of them. What's the probability that those are her favorite 10 stickers? So we want just those 10 stickers that her friend likes the best. So let's first find the combination of choosing 10 of them out of 20. So we have N being 20, R being 10. So if we do this, then this is like saying 20 combination 10. Just know that this is kind of the form that you might see for combinations. NCR, just like with permutations. And we can put it in and say 20 factorial over 10 factorial times 20 minus 10 factorial. Well, I'll let you take some time and figure all of that out. There's going to be quite a few numbers to actually multiply and simplify, but you end up getting 184,756 different combinations. That's a lot. How many of those combinations will have those exact 10 that are her favorite? Well, with a combination, there's only one of them. So it is a 1 over 184,756th chance of getting those exact 10 that are her favorite. Okay, so we can talk about probability with these combinations, but big thing here is it's similar to permutations, but we care about the order in permutations. We don't care about the order in combinations. So we changed this by dividing by all of the different ways to order those 10 choices that we make. I hope this video helps with your homework and for studying.